Hello everyone, welcome to Sweetie Speaks official YouTube channel. Today we are going to see von Neumann architecture. It is a part of computer architecture series. Let's understand what is von Neumann architecture. In von Neumann architecture, you have both instruction and data memory in the same memory. There is only one memory and you use it to store both instructions as well as your data. That is what is called as von Neumann architecture. This is the most widely used architecture in today's computers, like your personal computers, your laptops. These have mostly adopted von Neumann architecture. What does von Neumann architecture consist of? What are different components inside von Neumann architecture? Let's understand. The first one is CPU, Central Processing Unit. We are going to see all these components one by one. First, let's understand what are the components. First one is CPU. The second one is CU, which we call it as the control unit. It is a part of CPU itself. Then inside CPU, you also have ALU, which is arithmetic and logic unit, and you have registers. So the first component is CPU, which consists of your control unit, your ALU, and the registers. Apart from this, you have MU, which is the memory unit. Then you have IO devices, which are input and output devices. And you have buses to connect all these together. Now let us see these components one by one. First in line is CPU, which is Central Processing Unit. As the name says, it does processing. It executes the instructions of your computer program, which means it actually processes whatever instructions you are giving to it. It can also be called as microprocessor or processor or CPU. All these are same. What does CPU consist of? We saw it in the previous slide. It consists of ALU, which is arithmetic and logic unit. It consists of CU, which is control unit, and it consists of registers. You can call CPU as computer's brain because it does most of processing, like our brain does most of processing. CPU does the processing for the computer. That is why it is called as computer's brain. The CPU gets this information from the instruction. Which information do you want to process? Say for example, I have an instruction which says C equal to A plus B. So what information do you want to process? You want to process A and B. These are the inputs. Then how do you want to process it? Say the instruction is add A plus B, C equal to A plus B. It means add. So how do I want to process it? I want to add these A and B. This is the information that CPU gets from the instruction. Then what operation does it perform after getting this information? It will process your input. So it will perform the actual operation, which was A plus B. It will process the inputs A and B. It will store the data. So A plus B you want to store in C. So it will store this data and it will generate the output. Whatever is the result of A plus B, it will generate that and it will store the data. Let's see control unit, which is part of CPU. What does control unit do? As the name suggests, it is responsible for controlling. What does it control? It is responsible for all of the control signals inside the processor. It controls the operation of computers, ALU, which is arithmetic logical unit, memory unit, and input output devices. It controls the operation of all these components. How does it control? It decides how do you want to respond to instructions, and it performs below operations. It will get the code for the instructions. It will decide how the data will move throughout the system, from where you are taking the inputs, from where you are taking the output, uh, to where you are going to store the output, these kind of things. It will direct the input and output flow, from where your input should come, where your output should go. All these things are controlled by control unit. It will provide the timing and control signals required by other components. One simple example I am giving you. You will have memory inside your computer. Now, in order to access this memory will have an enable signal. Until and unless this enable signal is not up, you can't perform any operation in the memory. You can't access memory, you can't read and write. So this enable signal is controlled by control unit. So that once the enable is high, you can take the input from the memory. This is This means that your input will flow from memory to your processing unit. And say, for example, you want to display the output on your monitor. So this will also be decided by control unit, that the output needs to flow to the monitor. And then what will be the timing for this input and output data flow? That is also decided by the control unit. Now let's see about ALU, which is arithmetic and logic unit. This unit is the computing unit. It performs a lot of calculations. It handles all of the computations that CPU needs to perform. What are different types of operations which ALU performs? The first operation is arithmetic. Examples are add, subtract, multiply, divide. All such operations are performed by ALU. Then we have logical operations like AND, OR, XOR. We have bit shift operations. Example, shift left, shift right. All these different operations are performed by ALU. Arithmetic, logical, bit shift. Now what are registers? Register is a very high speed storage memory in the CPU. It is very closest to the CPU. So a CPU can access this memory very fast. It doesn't require a lot of cycles to access this register. All the data which you need to process needs to be first stored in register. Say for example, I was performing an operation C equal to A plus B. To perform this operation, I want to know what is A, what is B. The value of this A and B must be stored in the register before you want to execute this instruction. Let us see which are some of the important registers in CPU. Please understand this because we are going to use this terminologies a lot in computer architecture, and this is very important to understand what are different types of registers inside your CPU and what do they contain. First we have MAR, which is memory address register. What does it contain? It contains the memory location of data which you want to access. Then we have MDR, which is memory data register. In the memory data register, you whatever data needs to be transferred to the memory or from the memory, that data is held by memory data register. Then we have accumulator. There will be lot of arithmetic and logical operations which you need to perform, and there will be some intermediate results. All these intermediate results of arithmetic and logic operations are stored inside accumulator. Then we have PC, which is program counter, very important register. It holds the address of next instruction which you will be executing. Then we have CIR. CIR is current instruction register. It will hold the current instruction which is being processed. Let's revise since this is very important. MAR stands for Memory Address Register. It holds the memory location of data which needs to be accessed. Then we have Memory Data Register. Whatever data needs to be transferred to and from memory, that is inside MDR, which is Memory Data Register. Then we have some intermediate results of arithmetic and logic operation which are stored inside accumulator. Address of the next instruction to be executed is stored inside program counter. Current instruction which is being executed is stored inside your CIR, which is current instruction register. Now let's see what is memory unit, MU. MU is nothing but your RAM, random access memory. It can also be called as primary or main memory. What are advantages of using RAM? Now, if you consider hard disk or your secondary memory, we call it secondary storage, it takes a lot of time to access the data from it. Comparatively, RAM is the faster memory. This is one of the advantages of RAM. Another advantage is this RAM could be directly accessed by the CPU. Since it is faster, it can be directly accessed by CPU. That is why it allows your CPU to operate or perform the processing much quicker compared to when it would have been reading and writing the data to your main or not main, to your hard drive or secondary memory. So RAM is the main memory which allows your CPU to operate much quicker. What are IO devices? I stands for input, O stands for output. It means IO is input and output devices. Let us see. Input device is something which provides input data to your CPU. Input data means it will also provide the set of instructions to the CPU. What kind of instructions does the CPU want to execute? All that will be provided by your input device. What are some of the examples of your input device? Keyboard, mouse, microphone. So through your keyboard and mouse, you can, for example, through keyboard, you can type something. Through mouse also, we do some clicks which take you to certain different websites, say for example. So that is also an input. Microphone, through microphone, you are providing an audio input. All these are examples of input device. What is output device? Output device will receive the results from your CPU. Whatever data is processed by your CPU, that is received by your output device. Now this output device helps you to perceive, see, or hear the CPU output. Example is monitor, where you can see the output, printer. All these are output devices. What are buses? Bus is something which transmits your data from one part of computer to another. It will connect all your major internal components to CPU and the main memory. Because until and unless these components talk to each other, your computer is of no use. That is why bus perform this very important task of connecting your different components. What can be different types of buses? There will be address bus, which will carry the address of data between your CPU and memory. There is data bus, which will carry the data, actual data between your processor, memories, and input output devices. There is a control bus, which will control all the activities in your computer. The control bus will carry your control signals from CPU. We saw an example of enable signal, which is a control signal, which will control whether your memory is enabled or disabled. Then there are status signals. What is the status? Was the data transferred properly? Was there some error? These can be different examples of status signal. So these control and status signals are carried by the control bus. Let's revise because bus is also a very important topic. So bus is something which connects all your components together. There is address bus which will carry the address. Data bus will carry your actual data. Control bus will carry the control signals and status signals. Now let us see how your actual von Neumann architecture is going to be represented. We saw that the von Neumann architecture consists of different components. The first component was CPU, which was the processing unit which performs all the processing inside your computer. That is why it is called as processing unit. Now this CPU consists of different subcomponents. What were these subcomponents? There was CU, which was control unit. This will control the operations of your computer. Then we have ALU, which is arithmetic and logic unit. If you remember, it performs arithmetic operation like add, subtract, multiply, divide. It performs logic operation like OR, NOT, NOR, XOR, and it will also perform the bit shift operations. After this, we have something called as registers, and we saw that the registers can be of different types. First was MAR, which is memory address register. It carries the address. Then we have MDR, which carries the data, which will go to and from the memory. Then we have PC, which is program counter. It contains the address of next instruction. Then we have AC, which is accumulator. It contains the intermediate results of arithmetic and logical operations. Then we had CIR, which is current instruction register. It consists of current instruction being executed. After that, we had memory unit, MU, which is RAM or main memory, you can call. Then we had input device, which will give input to your processor. And then we had output device, which will take the result of your processor. To connect all these components together, we have something called as bus. For example, this is the input bus, which takes the input from the memory. Then we have the output bus to the memory, which will store the result of your CPU to the memory. Then from the input device, we are taking the input. So this is like something called as input bus. Then we have output of the processor is going to the output device. So this is the output bus. So all this which you can see in blue color, all these are buses. Now let's see what are advantages and disadvantages of von Neumann architecture. The first advantage is simplicity. As we saw in von Neumann architecture, both data and instruction are inside the same memory. Due to this, it is very simple. This is the first and foremost advantage of von Neumann architecture. After this, the second advantage of von Neumann architecture is flexibility. Again, we know that instruction and data are inside the same memory. Due to this, it is flexible. How much data is there, how much instruction is there, that is flexible. The next thing is it is faster. Why is it faster? Because your instruction and data are again in the same memory. That is why it is faster. And another thing is it is simple. You don't need a lot of headache to understand where is instruction, where is data, all that thing is avoided. So it is faster, it is simple, it is flexible, it is faster. The major limitation of your von Neumann architecture is bottleneck. Let us understand why do we have this bottleneck. If you remember, instruction and data stored in the same memory in von Neumann architecture. Due to this, both instruction and data share the same bus. So instruction and data can't be carried in the same bus at a time. At a time, either instruction will be carried or data will be carried. Both can't be carried at the same time, which means the instruction fetch and data operation cannot occur at the same time. This is one of the major limitation, which is a bottleneck. Now, let us see what are different applications of the von Neumann architecture. Applications means where is your von Neumann architecture being used. Some of the applications of the von Neumann architecture are: the first one is personal computers and laptops. Personal computers and laptops means they require general processing. That is what your computer and laptops are used for. And since they are mostly used for general purpose architecture, it is more efficient if you use a architecture where your instruction and data memory is same. Why? Because it will be simpler to use and it will be more efficient resource utilization, and it will make the software development very easy. That is why it is used in personal computers and laptops. The second application is microcontroller. What is microcontroller? Now microcontroller are like small computers which can be used in various applications such as, say, home appliances, like your microwave is a home appliance, then automotive systems or some industrial automation equipment. Why are they used in microcontroller? Again, because it is very simple and it can be easily adapted to fit the requirements of each application. That is why it is used in microcontroller. Then they are used in embedded systems. What are embedded systems? These are computer systems which are designed for specific tasks. Now, when you are designing something for specific task, we have constraints on resources and we need to use the resources efficiently. Example, memory. And again, in von Neumann architecture, we are using memory very efficiently. Since both your instruction and data are in the same memory, that particular memory is being used very efficiently. That is why von Neumann architecture is more suitable. Surprisingly, von Neumann architecture is also used in supercomputers. Now you will say that supercomputers means we need fast processing and this von Neumann architecture has bottleneck. How can it be useful in supercomputers? So in supercomputers, you should remember that supercomputers always have multiple processors and they always use very advanced memory management strategies. Due to this, multiple processors and advanced memory management strategies, this limitation of bottleneck in von Neumann architecture is avoided and it provides the simplicity which is more useful for the supercomputers. That is why von Neumann architecture is also used in supercomputer. To summarize, von Neumann architecture is something which has both instruction and data in the same memory. It consists of various components like CPU, memory unit, input device and output device. Again, your CPU will consist of various subcomponents like CU, which is control unit. Then you have ALU, which is arithmetic logic unit, and then you have register. To connect all these components together, we have buses. What are main advantages of von Neumann? It is faster and it is more flexible What is the major disadvantage? Is bottleneck. And applications are PCs, laptops, microcontrollers, embedded systems, and supercomputers. I hope with this you are able to understand von Neumann architecture in detail, and I hope these lectures are helping you. We will have a lot of more lectures in computer architecture and all other series. To stay tuned to such video lectures and understand all these concepts in easy language, please subscribe to Sweetie Speaks official YouTube channel. Thank you.